Hello, my name's Jason Galloway. I'm a researcher in the Agricultural Catchments program at Tragascan Island, and today I'll be presenting some of our work related to understanding the relationships between source pressure and water quality. Now, what do I mean about, what do I mean by the relationship between source pressure and water quality? Well, often we face the scenario described on this slide where Um, two catchments with similar source loads exhibit contrasting responses in terms of water quality. So that's to say that some areas show a strong correlation between source nutrient loads and water quality, whilst in other areas, perhaps this doesn't appear to be the case. So these differences, when they occur, they present us with an opportunity to understand some of the key processes which govern nutrient transfer. So, um, in order to carry out our investigations, we used the nutrient transfer continuum as a conceptual framework in order to formulate and answer our questions. So, the most important aspect of this framework is that events are needed to occur in succession. So, that's to say that if you observe a change in water quality, there must be pathways present, and prior to that, the nutrients must have been mobilized, and prior to that, they must be there in the first place. So it seems like quite an obvious and straightforward way of thinking, but it allows us to really structure our questions and gain a clearer understanding um, uh, in so doing. So I'll present a short case study which uses this approach focusing on nitrates, and in particular, I'll be focusing on the pathway part of the nutrient transfer continuum. A brief introduction to the agricultural catchments program. So it's a long-term research project. It's been going for a little bit over a decade now at six catchments in Ireland where there's a plethora of water quality that's measured on an ongoing basis. And to complement that data, there's also information on land management and yeah, a variety of other supporting information. Today, I'll be focusing on just two of these catchments. One, which is called Ballycanoe, is in the southeast of Ireland, and the other called Timoleague in the southwest. Both of these catchments are relatively intensively used for dairy farming. However, they have contrasting soil types, with Ballycanoe having poorly drained soils and Timoleague having well drained soils. So that'll be important when we think about our catchments in the context of the nutrient transfer continuum. This slide shows stream water nitrate this slide shows stream water nitrate concentration measured at each catchment outlet and nitrogen loadings for Ballycanoe on the top row and Timoleague on the bottom row. The leftmost panel is a time series showing the percentage change in annual stocking rate in the solid line and the corresponding nitrate concentration, which is the dashed line. And if you take a look at the differences between these two time series, between Ballycanoe and Timoleague, um, you can already start to see that there appear to be at least some differences in the relationship between the source pressure and the water quality. I'll we'll dig a little bit deeper on that in the next slide. But what I would like for you to take away from this slide in particular is the information in the box plots. The left box plot shows organic nitrogen loads, whilst the right box plot shows stream water nitrate concentration. And here it's a little bit easier to see that whilst both of our catchments have um, similar loadings, the water quality is actually quite different. So the source pressures are similar, but the response in terms of water quality appear to be quite different. Um, the red line, the red dashed line here, that is the drinking water standard of 2.6 milligrams of nitrate per liter. So yeah, so this is the crux of what we'd actually like to understand. We'd like to understand why there are these differences. Well, to start to understand what's going on, we can take a closer look at our catchments. Here we've divided each of our catchments into two groups. Farms with and without a derogation, which is the permission to farm more intensively than would otherwise be the case. In conjunction, we've also started looking now at stream water nitrate concentration in different parts of our catchment, so not just at the outlet. And reducing the spatial scale of our research in this way means that fewer processes are integrated and allows us to start to understand and disentangle individual processes more easily. On the right side of the slide is a time series of stream water nitrate concentrations, with the red points being measurements which come from areas which are more intensively farmed, so a higher source pressure, and the green points coming from areas which are less intensively farmed. The black line represents the stream water nitrate concentration at the outlet of each catchment. And the key thing to take away from this particular slide is that if you look at Ballycanoe and you compare it with Timoleague, the green and the red markers overlap each other a lot, whereas in Timoleague there's more of a separation between uh, the measurements which come from areas of high source loading compared to those with low source loading. And this this is really indicative of the soil type between these two different catchments. With Ballycanoe, which is poorly drained, there's uh, the poor connection or the lack of pathways obscures the relationship between the source pressure and the response. Whereas in Timoleague, where soils are more freely drained, this relationship between source pressure and the response that you can see in water quality is clearer. This is just a teaser, perhaps, of some of our findings. If you're interested in seeing how we incorporated meteorological data or how the story looks for phosphorus, or how these processes vary through time, or the differences between these processes during base flow or storm flow, then please follow our social media or get in touch with me via email. Details will be on the last slide. So to sum up, the relationships between source loading and water quality can be quite complex and can vary in time and space. But it's critical to understand these relationships in order to develop uh, effective and targeted um, policies to improve water quality. And with that, I would like to thank you for your attention and to acknowledge current and past members of the Agricultural Catchments Program for their continued hard work. There are a lot of moving parts, so I'd just like to say thank you to all the members of the Catchments Program, and also thank you to farmers who participate in the Catchments Program and allow us to install our monitoring equipment and to take samples on their land. And yeah, so once again, like if you would like to know more about anything that was presented here, please feel free to contact me via any of the means listed here. Okay, thank you.